First, let me introduce myself. I'm Chris Stirrat. I'm a program manager in the Windows CE Tools group. This is Matt Woodward, our lead developer in the data access area. We have a new agenda. We're excited to have a couple partners on stage with us today. We're going to do the first half of the session. Matt and I talk about our tools infrastructure and what we're going to provide, and then we're going to bring up SQL Server for Windows CE. They're going to talk for a little while, show a cool demo, and then we're going to have Sybase, one of our partners, come up, give a talk and show a cool demo, and then we'll all be available for questions at the end. So it should be a pretty good session. Okay, so we're going to give you a data access overview. Actually, let's get a show of hands in here. How many people have programmed against ADO? Okay, great. So I don't need to explain it to too many people. How many have done it for ADO for Windows CE? Okay. How many have ever programmed against OLEDB? Okay, good. So it's a lot of this I won't need to explain. So I'll go pretty quickly through the overview. Basically, data access is a key technology across all applications. We're introducing it into Windows CE because mainly of customer request. A lot of people want a much richer data access story and infrastructure in place on the Windows CE devices that they're trying to deploy. We see a need for it on the mobile devices, the handheld PC type devices, palm-sized PC for Salesforce automation applications. A lot of corporations are rolling out line of business applications. We've also had a lot of requests for people who are doing machine automation, controllers, telephone switches, kind of a wide variety of the true embedded type of systems. So a typical data stack on a desktop machine would look something like this, where you'd have an ADO programming model, which is basically the ADO object set. That's mapped down to an OLEDB object model. And then underneath that, that's kind of the jump-off point where people can innovate and we can have multiple OLEDB providers. And you see this on the desktop. There's a bunch of OLEDB providers, and what this really provides is the application people can write to a standard interface. The Visual Basic people typically would write to ADO. The VC people would typically write to OLEDB, and then they have a nice abstraction layer off the actual data store. And this provides a nice model. You can go to multiple different data stores easily. You don't have to worry about the exact data store that you'll be going to when you're actually writing your program. Okay, so most people understand what ADO is. It's a high-level object model, typically used in Visual Basic to allow you to get to your underlying data store. OLEDB, standard OLED-COM interface, provides access to all types of data. There's the standard OLEDB providers that you'd expect to see, like SQL Server, Sybase, Oracle. There's different ones that other people have written. There's companies like Marant out there that have done OLEDB providers to things like Lotus Notes and AS400. Basically, having that standard interface in place allows you to get to any other data source that you want. You can get to flat files. You can get to any different types of data that you want. OLEDB providers, like I just mentioned, various different types of providers are out there. On the desktop, there's companies that make their whole business on making OLEDB providers to different data sources. We're going to try and take that same model down to Windows CE. Okay, so the first thing I want to cover from the tools area is what do we have available today? What is shipping on the current devices that are out there? And what's our current model? The next thing I'll do after that is I'll move on to what's coming very soon, what's coming later this year, and how's that going to help you? And then thirdly, we'll talk about what's coming in the future, and then we'll get the partners up on stage. So today, the data access stack that we support looks like this. We have an ADO, what we call ADO CE, is the programming model that we have. It's VB applications typically write to it. VC applications can also write to it. It currently goes against the Windows CE object store or to what we call a CDB file. A CDB file is essentially, it lives in the object store, but it's its own, in the Windows CE file store terminology, it's its own volume. But on your handheld PC, it looks like it's just its own file. The key difference between the two of those is in the CDB file, it's a single file that will contain all your data tables. If you just use the Windows CE object store directly, then all your tables just show up as in the object store as tables listed out. They're not all contained in the same file. Given the choice, you should definitely use a CDB file. CDB file offers up a couple other features that we'll talk about in just a minute. But as you can see, there's no real integration point that we currently support today. If you wanted to provide your own data store, which a lot of people have done for Windows CE, we don't have an easy way for them to get mapped underneath our ADO CE interface. Okay, so what is ADO on Windows CE? Since about half of you have written to it, you'll know this, so I'll try not to go too deep into this. It's Windows-size ADO. I'm sure most of you already know by now, pretty much everything we provide in Windows CE is a subset of what's available on the desktop. If you expect it to be completely identical to the desktop, that's definitely the wrong expectation. These devices are on low-powered CPUs. There's devices that don't have a lot of resources, such as memory. And so we always are subsetting it, the desktop technology. We do try to take the correct subset, which is always very tricky. We have to look at what we can support, technically what we can support, and what we need to support based on customer feedback. So we're always kind of walking a fine line there. And we always want your feedback. So if you have feedback about objects that our current ADO CE doesn't support that you'd like to see, and I got some good feedback last night at the Ask the Experts, we'll keep those on the list to get them in as we move forward. One thing we try and do is be 100% compatible with ADO on the desktop. We take their test suites and we run them against our stuff to make sure that even error codes return with the same exact values, that the same behavior for the properties and the methods that we support. So what does ADO CE today provide over the current Windows CE database? Compared to the Windows CE database, it provides a couple new data types, double and Boolean, that we map onto the Windows CE database. It supports a SQL query processor. It's not a full-fledged what you'd expect to see on the desktop. It's a subset of that, but it does have support for where clauses, order by, creating tables, creating indexes, dropping tables, dropping indexes. It also provides a synchronization between desktop data and device data. We'll talk about that in just a minute. Currently, your database application architecture between your Windows CE device and the desktop would look something like this. On the desktop side, you'd have some application, your line of business application or whatever it may be, against your data source. And if you're going to set up a synchronization relationship, we currently support Microsoft Access and Microsoft SQL Server. And then on the device, you'd also have an application talking to the local database through ADO CE. And then the two data sources through ActiveSync, which is part of Windows CE services, will stay in sync. And you can set up a synchronization relationship between those. And there's a couple different ways you can set up that synchronization relationship. You can set it up, there's a piece of UI that allows you to do that. If you just took, say, an MDB file and drag and dropped it onto your Windows CE services, the mobile devices folder, it'll pop up some UI and allow you to set up your synchronization relationship. You can specify it down to the table level and the column level. There's also, from inside the mobile devices window, you can go to the tools, and in the tools there's two new choices that'll show up that say import data table and export data table. If you choose import data table, it'll pop up a piece of UI, let you browse to find an MDB file or an ODBC connection to a SQL Server database, and then you can set up your synchronization that way. A third way, which is the way I would actually suggest for most applications, is you can do it programmatically. There's two APIs that you would need to know about that are documented in the Visual Basic for Windows CE Toolkit, and they're called desktop to device and device to desktop. And essentially, these two APIs do exactly what the UI does. And so if you're writing an application and obviously you can't trust the users that you roll your application out to go to the UI and set it up exactly the way your application expects it to be set up, you can use those APIs to programmatically do it from the desktop. Okay, so I put this slide in here mainly to give a summary of what I just talked about with the synchronization stuff, so you'd have a printed copy of this. But just to touch on the important parts, We currently test and support connections to a MDB file or a Microsoft Access file and SQL Server through ODBC. We kind of have two different concepts as far as moving data between the device and the desktop. One of them we call filtering, which is really just the moving of data between one and the other and not keeping them in sync. So we'll take a desktop data source, filter it, allow you to choose which parts of the data you want to send down. We'll automatically build the tables for you down on the device according to the schemas that were on the desktop and move the data for you. So some people don't care about synchronization, but they do want to be able to move data back and forth. And so the filter mechanism allows you to do that. It's done exactly the same in the UI as it is in the two APIs I mentioned. It's really just a flag. When you set up the relationship, you say, should I keep this in sync or should I just send the data? Synchronizing data, then if you choose to synchronize data, the one thing you should know is it's only supported on the handheld PC Pro devices and above, meaning currently it would be handheld PC Pro and the new color palm-sized PCs. And the official version number on those palm-sized PCs is 1.2. And to use that, there's an SDK that we've put out on our website for free download. It's called the palm-sized PC 1.2 SDK. And we just re-released that about a week ago because the original release of it, they forgot to put in the ADO-CE bits. And so it's been re-released. So if you looked for it over a week ago and were disappointed because you didn't find the ADO-CE bits in there, please go download it again. The current version is correct out there. If you're going to set up a synchronization relationship, you must use a CDB file, which will be the default for all of the stuff you do on a handheld PC Pro and a palm-sized PC. It'll default to a CDB file. Okay. Whoops. Availability of the current stuff. On the HPC Pro devices, ADO-CE is in ROM on all these devices. It was actually shipped as part of the application Pocket Access. So you can, as a developer, you'll know on all of those devices it's already in ROM. And in the Visual Basic Toolkit, we ship the design time control necessary to program against it. For the palm-sized PC 1.2 devices, some of the devices are going to have it in ROM, some of them won't. Please download the SDK. The SDK has all the bits in there across the CPUs that are supported. So if you write an application and you go to install it onto a device that doesn't have ADO-CE in ROM already, it'll go ahead and install the ADO-CE components into RAM for you. On the handheld PC 2.0 devices, so these are the older kind of checkbook-sized devices, the HP 620LX, the Sharp Mobilon, the Compaq has one, all the previous devices. There is some limited ADO-CE support. We actually put out something on the web called ADO-CE SDK 2.0, and this gives you ADO-CE support. The only caveat is there's no synchronization support, but there is filter support, so you can move data using those APIs or the UI between the device and the desktop. You just can't set up a synchronization relationship. And starting in Platform Builder 2.12, which is due out later this summer, we are shipping the ADO-CE components compiled across all CPUs. This is a popular question last night. So x86 will be supported in Platform Builder 2.12. So anybody building devices starting with that version of the OS will be able to include ADO-CE and ROM across any custom devices, across all CPUs. So starting there. So that's fairly significant because we've had a lot of requests for people building their own devices, especially on x86, that want ADO-CE capabilities now. Okay, so that's what exists today. Let's move on to what's coming soon. And by coming soon, I mean we've got a target to release it in Q4 of this calendar year. OLEDB for Windows CE. So what we're trying to do is set up a model. If you went to the keynote, you saw kind of the overall picture that we're going for, which we'll get to in just a minute. We wanted to put a nice abstraction layer in place, same as we have on the desktop, to allow a lot of innovation in the space for the data sources. It allows all the partners, Sybase, Oracle, Rayma, all the people that have database engines for Windows CE can now plug themselves underneath our ADO model because we'll have the OLEDB layer in place. Our OLEDB for Windows CE is going to support the quote, base level of OLEDB interfaces. And if you go to the Microsoft.com website, there's a spec out there. It's the standard OLEDB leveling spec. And if you look at the base level support, that's what we require. That's our base level that we require. So we're not redefining some new OLEDB spec here. We're taking what the desktop says is their base level, and that's what we're starting with. Any deviations from that base level spec, we will publish in our own spec as part of our OLEDB for Windows CE SDK, which will also be released by Q4 this year. And once again, it's a standard interface. It provides a place for people to hook in their own providers. We've had people talking about doing their own OLEDB providers, that it's going to make a direct connection back to some data source on the desktop. That's perfect. We're giving you the place to do it. So on the device, your programmers can program either to OLEDB or ADO, and then you can hook in your own data sources underneath that do whatever you need them to do. So here's what our stack looks like once we provide our OLEDB pieces. So now we've actually got the same stack that you'd have on the desktop, where we've got our ADO object model, maps down to an OLEDB object model, and then OLEDB providers then can be plugged in underneath. So it's fairly significant in that we're completely opening up the architecture to allow all the innovation that people want to see for data sources. All the people that are complaining about performance or features of the built-in Windows CE database, we're opening it up so now other companies, third parties, yourselves, corporations can innovate in this space, provide the capabilities that you'd like to see. And later we're going to show you two of those. Can we hold questions till the very end? Okay, so how do you build an OLEDB provider? Basically, you implement the OLEDB for Windows CE spec, which again is the base level spec. That's the standard OLEDB spec that's out there. We're going to provide an OLEDB for Windows CE SDK to make it easier on you. It'll have the specification in there, some helper objects, which is the key ones are the error object and the data conversion objects. So those will help you. That's common functionality that you won't have to write yourself. So we're going to provide you some common functionality to allow you to more easily make your OLEDB provider. And that SDK, like I say, we're targeting for a Q4 release. And if you're interested in this SDK, this is typically the people who have database engines and things out there. Please contact me. We can talk about maybe getting you early drops of this or things like that. So please catch me after. I'll give you a business card so we can stay in touch. Okay, another way you can build a OLEDB provider is a toolkit called the OLEDB Simple Provider. This exists on the desktop. What it is essentially a toolkit that does a lot of the work for you, and you map this down to your specific data source. And it's used for quickly building an OLEDB provider for tabular data. So if you had a common delimited file or some fairly simple type of data source that you wanted to go to, this is a great toolkit. It does most of the plumbing and the work for you. And so it'll make your time to get your OLEDB provider done very quick. Now this wouldn't be used typically for like a full-fledged database engine. They would use the SDK because they'd need a lot more control than what this provides. But if you need to do something simple, we're going to provide this toolkit for you also. And again, we're looking at a Q4 release on this. Okay, with that, I'd like to hand this over to Matt Woodward. He's going to go ahead and demo a OLEDB provider that we wrote using the Simple Provider toolkit. So we can go ahead and show you how easy it was to build an OLEDB provider.
Looks like we've lost the switcher here.
Okay, so while he's coming up to fix the switcher here so we can show it to you, I'll just give you kind of a high-level overview. What we've done is we created an OLEDB provider to a comma delimited file. And we'll go ahead and show you what the comma delimited file looks like. We're going to show you a VB application going through ADOCE to the OLEDB, talking to this particular provider. We'll browse some data. We'll update some data. We'll show you the file again so that you can feel comfortable that we actually changed the data live right in front of you. And then we're going to show you a little bit of the source code that we actually had to write to implement this OLEDB provider.
So I guess the first thing, I'll just go ahead and start and say that if you guys want to familiarize yourself with the OLEDB Simple Provider Toolkit, or any of the other technologies that we're going to be building, a really good place to go and look is on the Microsoft.com website at the existing data access site. We're mostly doing direct ports and subsets of the data access components that are out there, so if you want to familiarize yourself, that's a great place to start. The OSP toolkit is the same, is pretty much exactly the same as it is there, so when I start showing you the sample, any of you have looked at the file OSP sample that's provided with that toolkit, you'll find that this looks pretty familiar.
There we go.
Should be ready to go.
That was okay.
What's it? It says it is.
We're going to demo it on a handheld PC Pro here. So what they're actually working on is getting the handheld PC Pro to VGA out, hooked up here. It did flash. Okay, so the demo's working really good here. You can trust me on that. I promise it's working. Yeah. Why, should we show the source code? Well, he needs the screen.
Show the source code here.
Okay. At worst case, if he doesn't get it working, we can show the source code that we wrote to actually implement the provider. But I'm sure he'll get it working. No pressure. Yeah. I'm going to go ahead and continue with the slides, and then by the time he gets this going, I'll accept you.
Can't do that either.
There you go. Okay.
All right.
Eddie Rodriguez here.
I'll try not to touch it or anything.
Okay.
Okay, so let's see how much of this we can do on this one device, and then we don't want to switch again if we can avoid it. So I just talked about the OSP toolkit, and what we're going to do is we're going to show you a provider that writes to text files.
Can we show the text files first?
Yeah, I'll go ahead and open up the text file. There's just a text file called t1.txt. It's got the row and column counts, and then it's got the names of the columns, and then there's the data. So we can go ahead, let's close this file. Now let's take a look at the app. And I've already got the app set up to open the t1.txt file, and I've set the provider, if you look at here, I've set the provider to the file OSP sample, which is the name of the provider that's registered. And we'll go ahead and we'll press select to query that data. And there you go. There's the data that just came from that file, and to kind of prove to you guys that I'm not faking you out here.
Okay, so the path he's going through with this application, it's a VB application written to ADOCE, which is talking to an OLEDB provider, which is the one that goes to a common delimited file. So he's going through the full stack here with the application.
So what I'll do here is I'll go ahead and I'll insert a row, and we can go ahead and requery. And we see that we've got a new row here. So just to prove to you guys that I'm not pulling a fast one, this is not a smoke and mirrors demo at all. Here's our text file, and there's the new row that I just added.
Okay, so it's a fairly simple provider that we built, but we built it to show you how easy it is to build them. It's a common delimited file. We're able to have full database access to the file. We can run queries against it. We insert rows against it, all through ADO, coming down through OLEDB.
So I'll try the scary switch away here. Well, while we're stuck here, I'll go ahead and show you the next part of my demo. We'll go to the code in just a minute. The other thing that I wanted to show here is that we are providing backwards compatibility and access to a variety of data sources, and we're doing that today. We support both the CEDB provider, so I'll go ahead and click here, and we're going to open another table called T1, which looks just like the T1 you saw, except the data is a little different.
The CEDB is essentially the CDB file that I talked about earlier. So he's taking in a file that exists today, something created with ADOCE today, and just to show that we have backward compatibility, we're going to continue to support that path through the data. So this is the same app now with a different provider string, and now it's connecting to that data source.
So I just queried that CDB using, and this is the exact ADO CE that you're familiar with now. And I'll go ahead and I'll run the exact same insert row code. And looks like we do have a little problem there, so maybe I won't run that code.
There's the real demo for you.
See, it is real. So we'll go ahead and close this. Oh, and the other thing we want to take a look at here, here's the same app again. We're just changing the provider string down here to look at SQL Server CE, and we're going to open the customers table. Let's go ahead and take a look at the customer table. So you can see this technology gives you a great way to get a variety of data with common application code.
Okay, so it was the same application. All he was doing is an ADO, you have a connection object that we're introducing. As we're mapping ADO to OLADB, we're introducing a connection object. He changed the connection string to the built-in CDB file, right, which is the built-in Windows CE database that it currently exists, and connected there and ran some stuff against that. We went to an OLADB provider that we wrote ourselves, which goes to a comma delimited file. We switched it again, and then we talked to SQL Server for Windows CE, all from the same application, just by switching the provider strings. So it's a pretty powerful model. It allows you to access any of the providers just by simple changing the strings of what you want to connect to.
I don't need to go back to slides in a minute, so.
Yeah, if you can't get that. If you can't get this up, we've with our OLADB Simple Provider Toolkit, we will provide this sample in the toolkit, so we'll provide full source code of what we wrote. So if we're unable to show it here today, we are going to publish the source code for the sample provider that we wrote to the comma delimited files for everyone. So that'll be the sample that's in the toolkit. So if for some reason we can't get it on the screen, but we do need the slides. The Windows CE database? The Windows CE database, it's kind of a general purpose database. It's also called the object store. It's used currently to store, all the PDA data, like your inbox, your task list, your calendar, all that kind of stuff is stored in there. It also stores all the registry for Windows CE stored in there. It's also the file system. So it's kind of a general purpose, we call it an object store, that's used those three different ways. And it's got some low-level C APIs that allow you to access it. ADO CE sits on top of there, provides you a SQL parser and things like that, so that you can actually have some SQL abilities against it, some additional data types and things like that. But it's a nice general purpose database engine. But if you're looking for a high-powered, robust relational database engine, that's why we're putting our architecture in place right now, so that people such as SQL Server for Windows CE, Sybase, and other people can innovate in that space and provide different, rich, fully featured database engines. Okay, so here's the source code.
So it's actually pretty easy to write an OSP. This is about 35, maybe 40K of C code. And what we're looking at here is get variant, and this is the main function that you have to implement. There's a few other kind of boilerplate functions that define your data source and that sort of thing. But this is really where you do the main part of the data access. And you get a row and a column and a format, and you're passed in a variant pointer. And all you have to do is take your variant, your data from wherever you might have it stored in your application. We happen to have this MRV table array here, and we just copy that into the variant, and you've just returned your data. So you might wonder, let's go a little deeper into this application, so you can kind of see how we go even below the covers. Here's this function load data. This actually takes the comma or the delimited file and loads it up. So you can just see here we open the file, then we get the row and column count. Then we build up our array, we allocate it, and then we go ahead and just read the file and stick it into the array. And that's all you do.
The total source code for the common and limited file OLADB provider that we had to write, or that you had to write, was roughly?
The source code size,
yeah.
The number of lines. I don't actually know the number of lines, but it's fairly minimal. It took me I wrote one of these from scratch for another data provider, and it took me about 3 hours to do it. So it's not difficult.
Okay, so let's.
So now let's go ahead and look at how you store the data. Storing the data is the same basic thing. You get a row and a column where you want to store the data. You have to fire a notification to the OSP toolkit, and then you just basically copy the variant into the table array. And then we call this function save data, which actually goes and saves the flat file back out. Notify that the event is done, and then we're all done. And in the interest of saving time, I'm going to go ahead and let you guys go to the Microsoft website. You can download the OSP toolkit, and you can check out the rest of the code for yourselves. It's all there. And I'll hand it back to Chris.
Go back to the slides. Okay, so I'll go ahead and talk through this slide while it's going, and then it'll catch right up to me. So one thing we are doing is changing ADO-CE slightly. ADO-CE, we will continue to maintain our backward compatibility to the existing ADO-CE. The key story a lot of people asked last night is if I want to start prepping for these providers coming online and things like that, should I write to ADO-CE today? And the answer is definitely yes. We're going to add some new objects to our current ADO-CE to support OLEDB, such as the connection objects, definitely necessary to allow you to connect to different providers. After that, we'll be adding in the command object and things like that. But the existing ADO-CE is compatible back with the desktop ADO. We will continue to maintain that kind of compatibility by using their test suites to test our code. And so definitely, it will not be changing on you. I mean, I can't guarantee there's going to be 100% as you move forward, but there's maybe minor tweaks. But it's definitely the model that we use is to keep our compatibility. So definitely, I would encourage you, if you're interested, write against the existing one today, and then as providers start to roll out, then you can start using the OLEDB providers, or maybe you want to write one of your own. In the OLEDB provider space, we are evangelizing to database vendors. We're evangelizing to third parties, especially the people on the desktop that have written a lot of OLEDB providers. We have contacted them. We have told them our story. We have promised them early drops of our SDKs to get them up and going. And so we're going to be out doing an evangelism tour there to try and get them signed up. The key thing we want to see is a bunch of OLEDB providers that can solve the needs that you'll have for your applications. We encourage you, if you're interested in doing one, if you have the need to do it, to contact me. I can help you get jump started on that. One area we should talk about is replication and synchronization. Replication and synchronization that ADO-CE provides today is kind of a basic level solution. Moving forward, when we have OLEDB providers in place, the synchronization is essentially based on the OLEDB provider. Each provider stores their own data in their own optimal way. They keep track of, there we go, they keep track of their of the changes that are being made, and so that they can apply them to their desktop database in their own way. So there's really no standard way that we're going to offer synchronization and replication. But each of the providers that are essentially database engines, such as SQL Server for Windows CE and Sybase, will have their own synchronization model to allow you to synchronize data between desktop and device. And what you're going to see is a much richer synchronization model than we currently offer with ADO-CE today, because they have full innovation, and they'll be able to do a lot more robust situation. Moving forward, one area that we've gotten a lot of requests for is to support a direct connection from a device to a network data source. So some people don't care about the local data store. They just want the direct connection back to the desktop data source or network data source. So that's something that's coming in the future. So that's not something coming Q4 of this year, but that's something that, if you saw the keynote, we announced that we're going to be supporting RDS, which is a standard on the desktop way for you to remote data between remote data sources and disconnected data sources. And so we will be looking at porting that code down first half of next year. And so that'll provide connections where the device can be the client to a network data source, and using the RDS technology, it can get the disconnected row sets, modify them, send them back, update the network data source, so you get a connection that way. And we're also going to support the reverse of that, where the device will actually act as the server. So if you had a network application that wanted to go out to the device, pull some data from the device, maybe this is a situation where you have a fleet of salespeople, and every night they dock their their device, and then you have an application that fires at midnight, goes, pulls data of the orders that they fulfilled or some information from that. It can pull it off. It can populate data on their device for the next day's rounds on their local data store. So moving forward, the 4 scenarios that we want to enable is a nice data abstraction with OLEDB to provide innovation, a nice open architecture. The replication and synchronization will be provided by the OLEDB providers. We're going to have connections where the device can be a client to a network data source, and then we'll have the reverse of that, where you can have a network application talk to the device as if it's a server. So that's the future of where we're going. We'd love your input. We'd love your feedback. And at this point in time, I want to go ahead and turn it over to our partners. The first one I'm going to introduce is Kevin Collins. He's from the SQL Server for Windows CE team.
Let's see if I don't have fat fingers. Ooh. Five and 4. Well, I'll go without slides. Maybe everyone can just come up here and gather around my notebook, and we can just start. My name is Kevin Collins. I'm the program manager for SQL Server for Windows CE. We had the announce yesterday, and we're getting some feedback here, that Bob Muglia did in the keynote, where you guys saw some stuff through Odyssey's software, where they actually took information down from SQL Server on the local area network, and then brought it down to our local data store, SQL Server for Windows CE, and then disconnected and updated data, and then resynchronized it back up. Today, if we're fortunate enough, we're going to show you a demo and kind of go over more of a drill down on actually what this product talks about. How many people went to the Tech Talk last night? A fair amount. I was looking for all you guys at Coors Field, but I didn't see anyone. So I didn't get any questions to answer. I know Chris was helping out with questions, but I didn't see anyone there, so maybe there was something messed up. I thought it was at Coors Field where we're going to do all this stuff, but it wasn't the case. Well, at least the Mariners won. Ken Griffey had 2 home runs, so any Mariners fans here? No Mariners? Oh, just a couple. I bet you everyone's Rockies fans, huh? Too bad you guys lost. Jeez. What we're going to show here is just a quick architectural diagram that kind of shows where we're going to fit in. Chris, is similar to what Chris talks about. What the Odyssey guys did is they actually had a VC++ app that went down through OLEDB CE, which is the preview stuff that we sent out to them, that Chris's team sent out. And then they used the preview of SQL Server for CE. And then they used some of their tools to actually get back up to SQL Server and do the replication that you saw in Bob Muglia's demo. I'm not going to do that. I'm just going to talk about the data store today. One of the overall goal of what we're trying to do is to add to the value of what is on CEDB today. And what we have is our targeted ship date is the first half of 2000 for us to get everything done. Obviously, we have a working demo here, but there's a lot more work that we still need to get done. Our goal is to have our DLL size be around 1 meg, and we'll just have one DLL, and it will be a native OLEDB interface. So you can get to us through Chris's new ADOCE technology that's going to call OLEDB, or you can write a VC++ application in CE and have it actually call our database. A couple things that we are going to have in it, obviously WinCE is all Unicode, so we're a native Unicode database. There's no ANSI conversion in there, so we're optimized for speed for that. For CE is everything, even our internal APIs are all Unicode based. We're going to have what marketing calls as a robust QP. What that means is basically we're going to support a union of the SQL grammar that's between ANSI 92 and ANSI 99 and SQL Server grammar to provide a good robust QP for everyone. Another thing that we're going to have that's kind of a level above what CEDB has is, if any of you were in the earlier talks, they talked about right now they have 4 levels of sorts, and the next version, the CEDA release, version 3.0, is going to go to 8 levels. Well, we have 128 levels of order by support, and I know you guys do that all the time, where you're sorting 128 different columns. So, any of those needs will actually be there. In replication, what we're going to do is we're going to actually support native merge replication in SQL Server, and you won't have any need to do what you do today where you actually go through the desktop through ADO-CE, the current version of ADO-CE. So it'll be a direct connect right out. We're going to have transactional support up to 9 levels deep that can be nested. So you can roll back on any of those levels and have business rules that you want to have defined at that. We're going to have some more data types that are going to be, our data type support is going to be in parity with SQL Server. That's our overall goal. Some of the ones that we're going to have that people have asked for that we've got feedback from the CEDB community is an identity data type or an auto number column. We're going to go a little bit beyond. We're actually going to allow you to update that or change the seed and increment value. Another data type that we're going to support that SQL Server has is a decimal data type. Other limitations that we're not going to have that CEDB has is we're going to have 32 indexes per table versus their 4 that they currently have right now. And we're going to have multi-column index support. So you can have an index over multiple columns and then seek on it. And we'll also support nulls both just in our columns and in our indexes if you want. Obviously, if you define a primary key, you wouldn't be able to do that. Our file size, if your device would support it, everyone's going to be buying those 8 gig flash cards pretty soon, so we know they're going to be wanting to use CE to store large amounts of data there, is we have a 4 gig file size limit. We're going to have referential integrity, which we're actually going to demo today with cascading deletes and updates. And another thing that we kind of have is a little bit easier database administration. For instance, if any of you have used CEDB, you know that when you define your indexes, it's done at database creation. You have to do it all at once. In order to switch a different column to have a different index, you have to rebuild all of them. What we'll allow, kind of like regular databases, is you to add or drop indexes as you desire. And we'll also support seek on multi-column indexes or on a single index. And you'll be able to seek on an index without actually closing the table. So you can switch indexes that you want to seek on while you have the table open. One of the things that we're kind of proud about is our performance over CEDB. We didn't actually think we thought CEDB was we're gonna have a hard time going against that, like I think everyone else that's a database provider that's gonna go there. So what we actually did from the very get-go was to actually do some performance tests using the native APIs in CEDB and our native APIs. So we didn't have any of the ADO-CE layers or anything in there to add any additional overhead. So what we did is a performance test where we were loading and updating 15,000 rows in RAM on a Jornada 820, which is the HPC Jupyter class device. And we did all the same data types that are similar between SQL Server for Windows CE and CEDB, and we indexed some of them and didn't index other ones. And for people that are using CEDB today, we did have a kind of performance tip for people that are actually still using it. And to get the best performance on CEDB, you always want to have the database uncompressed and not mounted. You always get the fastest results. If you try to use CEDB on a flash card, this 15,000 row test took over a day to run. So they're addressing some of those performance things in the next release of CEDB version 3.0 to work better on flash card support. But if you tried messing around with having the database compressed and not mounted, that's slower, or even having it mounted and uncompressed is still slower. We tried all the variations on that to see what the best performance was going to CEDB. So what we have is some performance numbers here. The first one is just where we're loading 15,000 rows with no index on any of the tables. And SQL Server CE did it in 19 seconds, and CEDB was 170 seconds. And you can see some of the different performances here. This is a seek updating a non-index column, and then a seek updating an index column where we just randomly choose a primary key seek to it, and then go and update the other values. So there's some good performance wins with SQL Server for Windows CE that we have right now. And this is just some differences here on when you actually create the index. We took 24 seconds to create those 4 indexes cumulatively across the 15,000 rows, and it was 6,261 seconds on CEDB. And this was with the fastest performance. Now, when you're just reading data back and forth, they're pretty much equivalent. There wasn't a whole lot of performance difference if you're seeking and just reading data. But any type of I/O type operations, we had some pretty substantial performance gains. So what I'm going to do now is I'm going to actually go through a demo. And I think what I'll do to play it safe is I will start here. What I'm going to do is just show you some of the code. And Dan, the guy who's coming up after me from Sybase, is we had a little bet, since we're kind of competitors, and even though we're not really a partner with Chris, we had a little bet on who could have the ugliest demo. So whoever wins the ugliest demo actually gets the win, and then that's who determines the best database technology. So I'm vying for the ugliest demo here, and I'm going to see if I can actually get to it. I think what I'll do is I'll play it safe, and I'll just show you guys some of the code here. Basically, all I'm doing is just loading in information. I'm going to retrieve it back out. I'm going to show some of the referential integrity that we have and demonstrate some of the cascading deletes and go through that, and it's going to be on a VB form. So as Chris already showed, what we're just using is a connection object here to load up. I know you guys can't see that when I highlight it, but this is the information, our connection string for regular OLEDB. We instantiated the new ADOCE connection object here, and then the record set, which is the same as what you do today in ADOCE. And then we're just going through and loading in data. And the reason I'm not going to do this on debug is Chris is also the PM for VB script. And if I go on the debug, I can't control the fonts. So I told Chris and Matt to bring binoculars for the people in the back, but they forgot them. So I'm not going to go to the debugger. I just have it running here on this Jornada device. If I can, ooh. So we're going to wait for me to go on that Jornada device as I have it running on the Jornada device. This was working fine before. Is it because the Rockies lost last night or something?
Where are you on?
I'm on 4. Or is it because the Avs lost? It is. It's not. We tested this before. I was here early and it worked. I think Matt was pushing the wrong buttons. Yeah, video, it was working. Oh, man. I tell you, I had this really ugly demo, too. When you do database stuff, you don't do fluffy UI stuff, so you kind of pride yourself in doing ugly demos. Yeah. There we are. See? Now, this is really ugly. And I went to the class yesterday, and that the VB guy, he might be here. I think that's him down back there. He was doing, he was talking about how, be big, depending on your device. So I changed my demo so I was big. I wanted to have big fonts and stuff. So I learned something here. So what I'm going to do is I'm just going to hit start. And the first thing what happened is I was loading orders. So I'm just showing you through the code here. We loaded all the orders and customers, and then we loaded orders. And then what I did here is I actually put in a customer ID that was a referential integrity violation. I didn't load any customer IDs that had a value of 1,000. So obviously in the customers table, I'd set up a primary key. I should go back one step and say, hey, how did this database get here? We created this database through OLEDB. Right now, ADOCE isn't going to support ADOX, so you can't create your schema or anything through DDL objects. And they don't expose all the command objects yet, so you can actually run queries through there. So we had to create it through OLEDB CE, and that's how we created the database. And when we created the database, we just created a customers table with a primary key that was customer ID, and an orders table with a primary key and order ID, and a foreign key and customer ID that goes back to the customers table. So what we have now is, and also in this version, the error objects aren't really working exactly perfect. But this is alpha software, so you guys don't understand that. And so what I did is I just put in my own trap that said foreign key violation. Oh, you guys can't see the screen and I can't switch back and forth. Well, you could all come around here and look at it again. What I'm doing here on this monitor, I'm not going to touch this. I'm just going to leave it. What we did is I actually put in an orders that had a customer ID of 1,000. So you can't see that. So what I did is I populated an error. So right there we validated our primary key constraints that we have native in the database. And can we really do this? Oh, yes. Hey, it works, Eddie. So where we are in the code before was this right here. We loaded in orders for one row succeeded. We loaded in another one. We got that referential integrity violation. And then what we're doing right here is we're just looping through to show you that, hey, only one row loaded into the orders table. So there wasn't like a bogus error message or anything. See, I tell you, it was Matt. And now what we did, I'm going to switch back to here. Boom, boom, boom. Yes. See, it works. It's just my fingers weren't as big. I displayed all the data, and we displayed the data to the 5 rows. So we treed the data back out. It displayed on the screen really fast, and then I deleted one row. And what I'm showing here is I deleted a row, and then that cascaded and deleted the row back into the customers table that I deleted. So when I'm actually looping through here, I put up, this is down a ways, you can see that there's no more rows in the orders, and that's what's actually being displayed right here on this error message, is that there's no rows in the orders table. So you can see there we just did a cascading delete, and boom, it went all the way down. So that's some pretty cool functionality that's not in CEDB today. Obviously, we're a little bit bigger footprint than CEDB, but we're providing more functionality. So see, Matt, it just works. So what we want to, I have to get off so my Sybase colleague here. Now remember how ugly my demo was, and then when you see his, who gets the ugliest, we'll do a thing at the end on question and answer on who wins that award. To end with, obviously this is a technology preview that we have. There's a lot of functionality that we currently have, but what we want to try to get back is more feedback from customers on what they feel is important. Primary is, do customers feel that 1 meg, around 1 meg, is way too big for their applications to deploy? Are they willing to give up more QP grammar to have that DLL size go down? Do they want to give up referential integrity to have that DLL size go down? We want to get information back from that. Also, we want to get information back on, are you guys happy with how replication works today? Are you happy with connectivity? Or is there other types of functionality that you want to see? Just today, I set up a alias that you can send email to us on and just give us all the information, and we'll get back to you to at least say that we got it or to drill down on more questions. Most of the people that I've been talking with on the news group didn't have the money to come to this event, so none of them are in the audience. So we welcome getting back more feedback. With that, I'm going to hand it over to Dan, who's just as anxious to see if this monitor works.
Can you hear me? Okay. I'm Dan Cummins. I'm one of the software engineers on the SQL Anywhere Studio development team. And I'm just going to switch over to our slides here. I got to switch over. Three, one. I think it's one. Good tech support here. I just want to tell you about our mobile database solution called SQL Anywhere Studio, which has been shipping since 1992. And if you've been following us in the market, we were previously known as Wacom SQL. So if you know about us from then, you would know that the database has always been designed to run in small places. It's designed from the beginning to be a small footprint database. In that market, recent report by DataQuest has declared us the industry leader with 55% market share, over 4 million deployed seats, and over 400 OEM application partners. There is a port of SQL Anywhere called SQL Anywhere for Windows CE. It's been shipping since mid last year. It targets both handheld and palm-sized PCs. The family architectures were SH3 and MIPS. That's what's currently shipping in version 6.0.2. We support end-to-end replication. As Chris was talking about, if your database engine, you might be providing your own replication and synchronization solutions, and we have that, and that's shipping in our CE version of our product. We provide graphical administration tools so you can manage your database and manipulate the schema from these graphical tools. Our product is it's our full engine. It has referential integrity, supports stored procedures, and it's basically the full engine ported to CE. Because it's been a small footprint database from the beginning, the footprint of the engine is less than 1 meg, and that's why we're able to get it onto CE so quickly. We have native code working on CE 2.0 and higher. The support I mentioned that's out there already is the SH3 and MIPS families. What we are moving towards SH4, PowerPC, and also there's a beta of the ARM support. I'm going to show you a little demo with our database engine running on my Jornada here. We have full transaction processing support, and our DB and log files are binary compatible with our desktop versions. There's no differences there. The replication technology, what we do is we replicate the transaction log to the consolidated database, say on a desktop. It's message-based, and we use email and file transfer protocols, and we leverage the ActiveSync protocol to do that. The data access architectures that we're supporting is ADO and OLADB as it becomes available. As Chris was saying, they're targeting Q4 '99. We're one of the people that contacted him, got an early technology drop, and I'm going to be showing you that in a minute. We also have a native ODBC driver and embedded SQL. If you want to program in C, you can write to those APIs as well. And to the demo. I don't know if I need tech support here again, or whether it will just work. Yeah, I didn't have it on. Sorry. It was in suspend. Got worried there for a second. I've already started the engine before, so I just thought I'd leave it running, but this is it down here on the taskbar. You can see it. And a very simple app, very simple demo, written in Visual Basic that goes against the ADO layer that we got from Chris. Very simple. We only have I just have the one menu item to actually issue the connect to our OLADB driver, which is what we're showing here, that we're working on it and it's in a workable state. The reason you know it's a real demo is because it took a second there to connect, in my case. So once it's connected, like a default SQL string shows up for me to execute here, so I can retrieve the row set, and it comes back. And this is this Jornada it's an HPC Pro with an ARM processor in it. So this is what this is what we're working on now. If you want more information about what I've talked about is shipping or what's coming up, you can visit CEDevCon. If you visited our booth, you might have gotten one already, but we had eval versions of the currently shipping 6.02 software. If you didn't get a chance to get one and you want one, you're interested, you can come see me afterwards, and I'll make sure you get one. And that is the end of my talk. Chris?
Okay, we're going to take question and answer now. All of us are up here, so if you have questions on any of the three things you saw, the tools, the architecture, SQL Server for Windows CE, or Sybase SQL Anywhere for Windows CE, please ask the questions. Yeah. Could you please step, there's a microphone right there.
Yeah, I had a question about a SQL Server for CE. You mentioned it was using an ISAM database engine. Is that different than SQL Server on the desktop?
The question was, is it different than SQL Server on the desktop? I just had ISAM to kind of break out functionality on the slides from QP to ISAM. This is a special release that we're doing of this, so it's not exactly the same code that's on SQL Server for the desktop. But I was just trying to break out functionality differences from ISAM to QP. It'll be integrated QP, like an RDBMS, like SQL Server is on the desktop. But it's not the exact same code base. It's a combination of code bases to get it down to that size.
Thanks.
This is a question for Sybase. Is there a way you can integrate Sybase server onto CE with a SQL Server on the desktop?
When you say Sybase server, do you mean adaptive server anywhere, the enterprise level?
Yes.
One thing I should have said was that for the replication technology, we have some middleware that allows you to replicate to a consolidated database, a backend that is not a Sybase database, actually any database. Your question was if I have ASE on CE?
Right.
Is that,
right.
The product that I was talking about here, I'm not so sure that the enterprise level database will be ported to CE. The small footprint database that we supply is on CE because it's the small footprint version.
But can you replicate that to a SQL Server on the
sorry, I got your question backwards.
desktop side?
Yes, you can.
Okay, thanks.
This question is directed at Kevin. When you were going through your code, Kevin, I noticed when you had your foreign key error, you were using the VB error to detect that there was an error. Do you need to go a level deeper into the ADO objects to find out what exact SQL errors happened there still?
Right now, it's an alpha. The question, everyone heard the question since he's on the mic, so I don't have to repeat it. Right now, since it's like alpha OADB CE and ADO CE, our OADB errors aren't getting propagated up to ADO CE at this exact moment. But it would be the same way as if you used any OADB provider on the desktop, that you could go down and get provider-specific errors. What we're going to return is we'll return an actual error number. And in the CE release, we're not actually going to have error strings because we're trying to keep the size of the overall DLL small. So to have all that, it's a good size reduction for us. So we're going to return our native error number and the actual OADB error number. Right now, all that wasn't functional, and that's why I kind of put in my hard-coded message in there, just so for the purpose of demonstration. But actually, when everything ships, and when these guys ship in fourth quarter, all that error functionality would be present. In this actual demo of ADO CE, I couldn't get the errors collections to work, so that's why we couldn't. But it will be functional.
Yeah, and just to clarify that a little bit, if you write an OLEDB provider or other OLEDB providers can provide error strings, that's just a choice that the SQL guys are making. And yeah, full error collection and error object support in ADO and OLEDB when it ships.
Thanks.
I was wondering if you could explain what the licensing is going to be for SQL Anywhere and SQL Server on Windows CE.
What the what should be? Sorry.
The licensing model.
I should get your name and get the real information to you. I don't know off the top of my head. I think it's per seat, and I think it's very similar to what we do for the desktop, but I'd have to get you the real information from marketing on that. If I get your card, I'll get it to you.
From SQL Server CE, actually I'm supposed to say SQL Server for Windows CE, otherwise legal will get on my case. So it hasn't been determined yet on how we're going to sell it for the CE device. But obviously, if you're going to do replication back up to the SQL Server on the local area network, then you'd have to have a CAL for that. But the actual licensing scheme to actually purchase this product hasn't been determined yet. We're still trying to get feedback from customers and everything to see what's going to actually work for them on that. Since we're not releasing we're releasing next year, so we haven't actually finalized how we're going to sell it for the CE device. I can guarantee you it'll be a license connection that you need to get to the server.
I have another question, which is what advantage would I have to choose SQL Server for Windows CE versus like Pocket Access?
Right now, Pocket Access talks directly to CEDB, and all Pocket Access provides is queries and a mechanism to actually open and browse tables. Pocket Access doesn't expose any mechanism to actually code to VB or anything like that, so you can't really do an application with Pocket Access. It's undetermined. They haven't announced their plans yet on the next release of Pocket Access, when that's going to be. They're talking about when they do the next release of Pocket Access that they would have the ability to talk to SQL Server for Windows CE. That hasn't been determined yet. So to answer your question more specifically, is today, or when everything actually ships, you would be able to write a custom VB application with code that can get to SQL Server for Windows CE. And then you're going to have all the other benefits that we have of referential integrity, better data type support that's synonymous with SQL Server, and be able to actually code to it, and better performance.
This is a side-based question. Can you tell the difference between your ultralight and SQL Anywhere? I don't know if I have the name correct, but.
Yeah, there is an ultralight product. The ultralight product is a different product where you can basically customize the database engine to fit the application you're writing. So you can write an application, say in embedded SQL, and it can analyze your code, the SQL statements in the code, and it figures out the minimum set of the engine that it needs to have present to support that application. Then it generates the engine and binds it. So it actually trims down the engine so that you can fit it onto super small sizes, like 50 to 100K. But the SQL Anywhere product that we're talking about here, and the OLEDB driver for that, that's a full port of the full engine. It's not trimmed down in any way, so they're slightly different. We didn't. The OLEDB support is only in SQL Anywhere right now. That's why it's in this presentation.
In your ultralight version, are you still using the DB files, or are you writing to the object store?
I believe it's still DB files, but I better I can check and make sure if you give me your email address, I can find out for sure.
Thank you.
Hi, this is a general question. For transactions, don't you need something like a flashcard or something where you have a log and everything is committed instead of staying in RAM? So when you're doing your performance test showing how SQL Server works on the performance on RAM, shouldn't we be concerned about performance on flashcards?
We actually did. We did do performance tests, and we actually work on a flashcard. And there is just because of the mapping layer to go from a flashcard which supports FAT versus RAM on the CE device, there's a performance hit just for that conversion. The delta that I showed in RAM is even more significant on a flash card between CEDB and SQL Server for Windows CE. I didn't want to show, I could have showed that slide, but it just would have been these long bars up and down. The delta of performance between CEDB today, what is shipping today, in RAM versus storage card is significantly bigger than it is on RAM. So if you look at we're slower on flash card just because of the translation layer, but we're still even more significantly faster than CEDB today on flash card. Now, version 3.0 of CEDB has just specific things in there to optimize performance on a flash card, but we haven't been able to do our own internal performance testing of that yet to see what the performance improvement was.
And actually, to follow up on that a little bit more, when Kevin's talking about the database being in RAM, he's talking about the Windows CE file system in RAM, which is battery backed. So you really can have a transaction log in a file along with the data in RAM. You don't necessarily have to move off onto a flash card.
But is there a fear, like for example, a salesperson is out there all day collecting data, and if you lose your power, you're lost. I mean, even if you lose your backup battery and the main battery, you've lost all valuable transactions before it gets synchronized with your server.
Yeah, I think that's good input for Kevin there.
I believe you were saying that if you lose your backup battery and your main battery, then you're going to lose the database. And that's a true statement. And what you have to do is choose, if you want to go to a flash card to have that, that's just the performance hit you're going to have to take to actually have that. We don't have the ability to store our transaction log on, currently we don't have the ability to store our transaction log on a flash device in our database in RAM. That you might want to post that to us on the wish list to see if that's a feature that you want. But it's even the same way with CEDB today. You'd have to put your database on a flash card to guarantee that if you lost your backup battery and your main battery, that your data would still persist.
Thank you.
One thing I'd like to mention too is for the solutions up here, for the toolkit and the enabling technology, and for SQL Server on Windows CE, I can speak for both of those, is we're going to release these toolkits, these DLLs, the components, the engine, across all CPUs. This is not going to be specific to the mobile devices. So those of you sitting in the audience that are building your own custom devices, this is technology that's going to be available to you through the platform builder. So in addition, you're going to see it on a lot of the mobile devices. It's also going to be fully available to you on any of the custom devices.
Okay, I have questions for Kevin. Isn't limitation on number of joins for SQL Server CE?
Can you repeat the question? I didn't.
Is there a limitation on number of join of the tables?
The question was, is how many joins are we going to actually support for those of the people that got blasted out? Eddie, you're killing me. Right now, we're getting customer feedback to see, because the increased number of joins that we're going to support increases how big our QP is actually going to be. So we don't have a hard number on that yet, on what we're going to actually, the number of inner joins that would support. We're still looking to get customer feedback to see what the actual suite number is for us to keep the DLL size at a minimum, but still provide the maximum functionality. So we haven't finalized that yet, on actually how many inner joins we're going to allow to support.
Okay.
That outer joins is also another question that we're looking for customer feedback. If a whole bunch of people say that they want to have that in our QP, we won't rip it out, and we'll leave it in there. And we just got to get back. We're really trying to determine what's the sweet spot in our DLL size. Right now, it looks like we're about the same size as Sybase, and we need to get feedback from customers if that's acceptable on PPC devices that have limited amounts of memory. Are we the right size? And that's really what we're trying to struggle with right now, is we have all this functionality. How can we make it smaller to actually solve your guys' needs so that's what's acceptable to run?
Another question is do you support computed column in SQL View?
The question was, is computed columns? Are you suggesting a computed column that would be like in a create view statement where you'd say column 1 plus column 2 as, yeah,
That's
that's
correct.
something that we want to support. As is something that CEDV doesn't have would be aggregates is another thing that we're looking to, that we want to also support. The aggregates that are defined in ANSI, like sum, average, minimum, max.
Okay, thank you.
Any other questions?
Who won the ugly demo? All right.
Okay, thank you very much. And then like I said before, if you're interested in writing an OADB provider, you want to get an early drop of the SDK or talk to me about it, please contact me. And thank you very much for coming.